Hi, and welcome to, I guess, the second video with regards to variations or proportions, sometimes as they're known. So in this video, I'll talk about partial variation, which is a little bit different than direct variation or direct proportion. So if you want to watch the video on direct proportion or direct variation, I'll put up a link up above, so you should watch it before you watch this video. So in that video with regards to direct proportions or direct variations, what we have or what we had was you basically have some input which you want to be able to scale. So either make it larger or make it smaller. So we're scaling it up and down. And I showed this by having this little diagram of an input. And then what we were doing is we were scaling that input by multiplying it by some factor. And this factor we called the constant of variation or constant of proportion, okay, or proportionality. So constant of, I'll just put variation. You can certainly use proportionality if you like. And the way that this would look is if you have your x coming in, so basically your x is being multiplied by your k, and then you have your output, and your output was y. And that output, okay, so we see here, and then your input is right there. And all of these different types of direct variations basically were just a straight line. And that straight line was passing through zero, and it was going up or down depending on how you are scaling something. Now, in partial variations, what happens is that we basically take this, and what we have is we just change it ever so slightly. So let me copy it down here. So I'm going to copy it. Okay, let me shift this down. Okay, and I'll make it smaller because what we're going to do is we're going to be adding something to this little diagram. So if you understand the direct variation concept of the multiplication by some scaling factor, then what happens next is, okay, so our output, so I'm going to delete the output here, and instead what I'm going to call this is I'm going to say that this is my output number 1. And that is just a scaling factor of k. Now, if you have a partial variation, what also happens is that now, okay, so what we have is we take this, so let me copy this, so paste it right here, and what we will have is we're going to have another different type, okay, of scaling, but now we're no longer going to be scaling this, we're going to be shifting it. So you have your scaling of k, which is your constant of variation or constant of proportionality. And then what you're going to have is you're going to have another different, okay, type of a shift. So you're going to be shifting this by some factor. I'm going to call this factor b. So all that you're doing is, so this right here, what we saw from this, okay, was some kind, so this is my y1 is equal to kx. And now all we're going to do is to get our full output, okay, so now we're going to get our full output y, is we're going to take this little, okay, so this right here, so this kx, and we're going to be shifting it by, so I'm going to paste this, okay, right here, and we're going to shift it by some constant b. And that is going to give you your full output y. And we call this partial variation because we are partially varying here, and then we're scaling or shifting right here by this constant b, right? So we're just basically scaling it up. Now, where do we see this? Well, a nice example of this is actually if you had to do a changeover from temperature, which someone might be used to in degrees Celsius, and then they wanted to see, okay, what the change of temperature would be if you wanted to have it in degrees Fahrenheit. So, for instance, if I copy this entire thing here, so let me do that. So I'm going to copy this whole thing right here, and I'm going just to show you. So on an actual example, so here, so what we have is, so this is my partial. Now I'm going to make it very specific, so I'm going to get rid of these. Okay, now my inputs and my outputs, okay, are also going to be specific. So I'm going to just do that. Okay, let me just remove this right here and then draw this and connect it all here together. So we'll do that. All right. So with our temperature, so our input, if you can imagine that our input was, for instance, degrees in Celsius. So that's our input. And our output, what we want is, we want to have our output in degrees Fahrenheit. So we want to be able to create a relation between the degrees Celsius and degrees Fahrenheit. So what happens in this situation is that you're scaling your constant of variation, your K in this case, okay, would be, you'd be scaling it by 9/5. And this is basically just coming from the conversion between degrees Celsius and degrees Fahrenheit. So we're going to be multiplying our degrees Celsius. So we're going to be multiplying it, right? So that's going to be happening, and we have our little first output. So this is going to be 9, okay, all over 5 right here, multiplied by degrees Celsius. And then what we will do is we're going to be shifting it, okay, and it turns out that our shifting factor is 32. So we're going to be shifting it by 32. So if you now look at this overall equation, okay, this relation, it would be, so my output is degrees Fahrenheit. It is equal to, all right, and now we have, so 9/5 multiplied by degrees Celsius plus, okay, 32. And you can see now that you can do this translation, and what happens really is, it is just a shift of a direct proportion, okay, in this case by 32. So let's take a look and see what would happen if we would be doing some little bit of a table here. So we have degrees Celsius, and then what happens in degrees Fahrenheit. So I can do that. All right, and now, so 4 degrees Celsius, so as we're walking through this, so let's say, you know, we started at 0, okay, so this is 0 degrees Celsius. Let's say then we wanted to have 5 degrees Celsius, so we're going to be moving up by increments of 5, okay, so let's say we wanted to have those 4 inputs. So if you take these and you input it into your little equation here, okay, your partial variation equation. So what we would have is, well, 0, if we substitute 0 inside there, then 9/5 times 0 is just 0. And our answer to this would have been 32 degrees Fahrenheit. That's what we would have there. Now, if we substitute 5 inside there, so 9/5, right, times 5, so that would have been 9. 9 plus 32, all right, and that would be, okay, so in this case, it would have been 41, all right, so that's what happens to that. And now 10 degrees, if you take 10 degrees and you substitute it into your equation, you would have 10, okay, times 9/5, okay, so that would be 18, and 18 plus 32, okay, so that would be 50. And you can continue with that, okay, so the next one, 15, right, and you can see that I'm going to just take it out on a calculator here, okay, so if we put up a calculator, so I just want to show you, so I have 9/5, and that is being multiplied by, so let's say 15, and then plus my 32. So the other ones I was doing in my head, so here this is what you have, and in this case, okay, you'll notice that this would have been 59. So you can have this, okay, and overall, this is basically your K, your constant of variation. So that's the 9/5. And then this is just your shift that you have. and here you are shifting it by 32. Now, what you should also be able to do is you should be able to graph this relation between these two. So in this case, what we would have is if I was graphing this out, so let's say if I graph it like this, all right, so now my degrees Celsius, okay, is the independent variable, and then degrees Fahrenheit would be my dependent variable, and I did it in increments of 5, so maybe that's what I'll do here. So 5, 10, and let's say 15. And notice what happens is that at 0, we are actually starting at 32, right? So that's what happens there. So this, let's say our start would have been, okay, at 32, and that's our starting point, okay, in order to map this. So 0 and 32. And then 5 would have been at 41, okay, and then at 10 it would have been at 50, and then 59. So what you would have is you would have this kind of nice going up, okay, in terms of that. Maybe I didn't do such a great job in terms of, that's a little bit off there. So that, okay, so this right here, okay, so it would have been somewhere over here. And you have these points, all right, where this would have been 41, this would have been 50, this would have been 59, okay? And it would continue on, okay, as you would progress through. So that's a partial variation example with temperatures. So now let's take a look at the difference between a direct and a partial variation. So just quickly go over it. So number one, so remember that your direct variation or your direct proportion is going to look of the nature as y is equal to some scaling factor, all right, multiplied by your input. Your partial variation, so the key difference is that you do have this, but you are also partially shifting it by some constant b. Now, what does this mean? Okay, so the most important thing is that both of these are actually, if you graph them as a relation, so they are both lines. So both this is a line and also this is a line. The only thing is that this, okay, one right here, okay, this line will always go through 0. And this line will always be shifted and will go through B, okay? So whatever that particular B is, so right here, whatever you have shifted by, all right? So that's what you would have, and that's really the only difference. So now if we would look at some particular examples that I would throw up at you, okay? So here, so for instance, if I would give you y is equal to 1 over 4x, so this one is definitely an actual direct proportion or direct variation, okay? So there is no shifting at all. If I gave you something like this, all right, let's say 2x plus 8. So right away, because of the shift that you see right here, then this is a partial variation that you have. Now, please don't get fooled, because sometimes what you will have is, you know, that might be written out in this format. Adding, you know, and swapping them, okay, side by side doesn't really make a difference for us. So both of these are actually the same. So this is the same thing as that. And that's what you should look out for when you are looking for these direct and then partial variations. So are you only scaling something, making it bigger or contracting it, or are you also shifting it by something? And as soon as you shift it, then that would be a partial variation. All right, thank you for watching. I hope that you found this useful, and we'll see you in the future videos. All right, the next ones I'm going to tackle is going to be on slopes and basically rates of change, which are the same thing. All right, see you in the video. Bye.